Hello everyone, welcome back to the Electrical Circuits and Network. Today we are going to discuss nodal analysis. Okay, what is nodal analysis and what are the steps to follow while solving a given circuit to find the unknown voltages and current. This nodal analysis is based on the Kirchoff's current law, which we already discussed in the last session. Also in the last session we have given one task to solve, and we are going to solve the task in this session. Okay, so let's get started. These are the students which have commented the correct answer for the given task in the which was given in the last session. Okay, so congratulations to them. And this was the question. This was the question given in the last session, where we have to find this current I. This is the current. Observe here, there are three nodes. This one is node, this one also node, and this one also node. So we know that using KCL at each node. Using KCL at each node, we know that the KCL says that total incoming currents are equal to total outgoing currents. That means sum of all incoming currents is equal to sum of all outgoing currents at any node. Okay, so we will apply this KCL at each node. This is this will first, this will be the second, and this will be the third node. See here, this is the first node. Apply KCL here. Now the incoming currents are what? This 5 ampere, okay, and outgoing was 1 ampere. So 5 is incoming, that means 5 should be outgoing. So 5 is incoming, so 1 is outgoing. So 5 minus 1 remains 4. 4 will be outgoing here, because this 4 plus 1 is 5, and which is equal to this 5. So this 4 ampere will be current flowing here. Now see at 2, apply KCL here also. At this point, 1 is incoming, 2 ampere is also incoming, that means incoming with positive 1, this also positive 2, and the outgoing will be what? This will be the outgoing current. So 1 plus 2 is 3, 3 will be outgoing. Okay, so this will be the 3 ampere, because 1 is coming, 2 is also coming, so leaving this node current will be 3 ampere, sum of these two. Okay. Now see here, at this node 3, 4 ampere is incoming, 3 ampere is incoming. So 4 plus 3, 7 ampere. So outgoing current I will be plus 3 plus 4 is nothing but plus 7 ampere. So outgoing current will be 7 ampere. So required value of current for this given task will be 7 ampere. Okay, this is the required correct answer. In this way, we can solve with the help of KCL. The unknown current can be found out. Okay, so let's discuss the nodal analysis. The nodal analysis is used to determine voltages at different nodes and currents in all branches. This is mainly used to determine voltages at different nodes. Suppose we have given one circuit and we want to find the voltage at each node. Then this node analysis is useful. And this is done by using KCL. This we have already discussed. And what are the steps in nodal analysis? The first step will be, when we have given a circuit, then first we will identify and mark all the nodes and node voltages, including reference node. Okay. In first step, we will identify and mark all the nodes and node voltages. Suppose this is the circuit given. For example, this is the circuit given. Then what will we do? Identify and mark all the nodes. Okay, this will be the node, and this will be the node. Okay, this is the voltage source. So identifying this Vx will be, and this is the common for all branches. So this will be the reference node. Okay, V0. or V reference. This will be the reference current. In this way, we can identify and mark all the nodes and write their node voltage. At this V reference is always 0 because this is the reference and which is connected to ground. So this voltage at this reference node will be 0 volt, and this will be the voltage we have to find. This Vx is 40 volt. Okay. Then mark all the branch currents. Here, suppose this is node, then this will be the current or this will be the current, and in this way we can mark the current. Then write the KCL equation at every node. Apply the KCL at every node and write the equations in terms of current. This will be our third step. And then transform this KCL equation into matrix form and solve them to obtain various node voltages. We can solve this KCL voltage with our ordinary method, or also with the help of matrix method. Okay, these are the steps we are going to follow. So let's see problem here. The question is, determine the current through 20 ohm using node analysis. This is the given circuit. Okay, this is the given circuit, and we have to find the current through this branch. Okay, that means I 20 ohm, we want the value of I 20 ohm. See here, this is the branch which is connected between this point and this point, and this is the reference node VR, which is 0 volt, and this is the node voltage. So here only one node is there, so name it as a V. Okay, or Vx. Then we have marked here the identified node and mark the node voltages. Then this is the positive terminal, so current will be here. This is the positive terminal, the current will be in this manner. Okay, so first we will write or apply Kirchoff's current law at node X. Okay, this is the X node, so we are going to apply KCL at X node. So now let's see, suppose this will be the current, and always assume that when we are applying the KCL at any node, assume that the node voltage is greater than all the other voltages. That means Vx is greater than 50 volt, Vx is greater than 100 volt. Assume that. Okay, this is the procedure Vx. So this current will be what? This current will be what? As it is more than, we assume that Vx is more than the voltages connected in the circuit. So Vx minus this 50. So Vx minus 50 divided by this 15. Okay, then plus Vx divided by 20 plus Vx minus 100 divided by 30. Vx minus 100 divided by 30 is equal to 0. That means sum of all currents at each node will be equal to 0. This statement we are using here. So in this case, this will be the current direction and this will be the current direction. Always assume that the node at which we are going to apply the KCL having the highest voltage among all the voltages in the circuit. In this assumption we have to do. Okay, then this will be the voltage divided by its resistance, that means current. This will be the current flowing through 15 ohm, this will be the current flowing through 20 ohm, and this will be the current flowing through 30 ohm. Okay, so first we will common, this Vx is common between these three, 1 upon 15 remaining, this 1 upon 20, okay, this 1 upon 30 into Vx equals to, this is minus, this is also minus, so take it to the right side, so 50 divided by 15 plus 100 divided by 30. Okay, now this is the equation we have. So take LCM of this 30, this will be 2 plus 1.5, okay, and 30 this is also 30, this is also 30. So 1 into Vx is equal to 30, 100 plus 100. That means this 2 plus 1 plus 1.5 is 4.5 divided by 30. Vx equals to 200 divided by 30. This equation we got. Okay. We have this equation 4.5 divided by 30 into Vx equal to 200 divided by 30. So this 30 and this 30 will cancel, and Vx equals to 200 divided by 4.5, and the value of this we will get 44.44 volt. Okay, this is the value of node voltage. This is the value of node voltage. See here, this is the Vx value. We have got 1444 into 44.44 volt. Now we want this I20 ohm value. So Vx divided by this 20 ohm, because the potential across this Vx minus 0 is nothing but Vx. Okay, divided by 20 will be the I20 ohm. So required value I20 ohm will be Vx minus 0. This is the voltage difference across that branch, 20 ohm divided by 20 ohm. So Vx is 44.44 minus 0 divided by 20 is nothing but 2.22 ampere. So the required value of current will be what? 2.22 ampere. In this way, we can find the required branch current with the help of nodal analysis. This is when we have only one node. Let's see another problem where we have more than one node. This is the question. Here, determine the current through 5 ohm using node analysis. This is the given circuit diagram. Here, identify first node. This is the node 1, this is the node 2, okay, and this is the reference node. This is the reference node which voltage is 0 volt, and this will be the first node, suppose X, and this will be Y node, okay. And we are going to apply the KCL at each node, and we are going to solve the equation. In the previous question, there was only one node, so one equation we got. Here there are two nodes, so two equations we have to solve. So first we will write the equations. First, in first step, apply KCL at node X. So node X, and voltage at this node X, voltage at this node X is Vx, and voltage at this node Y is Vy. Okay, so assume that, and when we are applying the KCL at node X, so voltage at node X, we will assume that it is higher than all other voltages. Okay, so Vx, so all the currents are outgoing. So at this X, incoming currents are equals to sum of incoming currents are equal to sum of outgoing currents. So at this X, this 3 is incoming, so this 3, positive 3, this is outgoing, so minus Vx minus V reference divided by 6, and this is also outgoing, and the potential difference across this 5 ohm is Vx minus Vy. So minus Vx minus Vy divided by 5 equals to 0, because at this X node only 3 branches are meeting, this one, and this one. Okay, so we have these 3 terms. Now this V reference, we know that this is 0 volt, so equation will be 3 equals to Vx divided by 6 minus plus Vx minus Vy divided by 5. Now rearrange this equation. This 1/6 plus 1 upon 5 of Vx minus 1 upon 5 Vy equals to 3. Okay. This 1 upon 6 plus 1 upon 5 into Vx minus 1 upon 5 Vy equals to 3. We have this equation. Let's take LCM upon this is 6 into 5, 30. So this will be 11 Vx minus this 1 upon 5 Vy equals to 3. By rearranging these terms, we will get this 11 Vx minus 6 Vy equals to 90. Okay, this will be our first equation at x node. Okay, and this will be the first. This is 90. Okay, then similarly apply KCL at node y. Okay, so by applying KCL at node at this y node, we are going to apply. This is outgoing current, and also from this will be the, when we are applying the KCL at this y node, the voltage at y node, we assume it as the highest. So this at this, the current flowing through this branch will be Vy minus Vx divided by 5 plus Vy divided by 1 plus 2 ampere equals to 0, because all are outgoing currents. So we will write this Vy minus Vx divided by 5 plus Vy upon 1 plus 2 equals to 0. So let's rearrange 1 upon 5 Vx plus 1 upon 5 Vy equals to minus 2. Okay, then this, let's arrange this. So this will be the minus Vx, this is 5 into 1 5 plus 1 6 plus 6y and whole divided by 5 we have. This Vy equals to minus 10 when we arrange this taking LCM. Okay, on both sides. So this will be the minus Vx plus 6 Vy. This is Vy equals to minus 10. This is the second equation we got from the y node. From this first and the second equation, we have to calculate Vx and Vy. Okay, let's take sum. Equation 1 plus equation 2. What will happen? This will be the sum 11 Vx minus 6 Vy equals to 90 minus Vx plus 6 Vy equals to minus 10. Okay, minus 10. So sum this minus 6 and plus 6, this will cancel. This 11 Vx minus Vx is nothing but 10 Vx equals to 90 minus 10 is 80. So Vx value will be 80 divided by 10, which is equal to 8 volt. Okay, this is the required Vx value. Now see here, this is the 8 volt. Now put this 8 volt in any of this equation and find the y value. So putting the value of 8 here, this will be the minus 8 plus 6 Vy equals to minus 10. So 6 Vy equals to minus 10, and this will be the plus 8, so minus 2, and Vy equals to minus 0.33 volt. This is the required value of Vx. Okay, but this question asks about the current flowing through this 5 ohm resistor. We want the current flowing through this 5 ohm using nodal analysis. So this 5 ohm. So Vx minus Vy divided by 5 or Vy minus Vx divided by 5 will be the answer. So let's do this the Vx value is what? Vx is 8 volt and Vy value is minus 0.33 volt. So this will be the higher. So I 5 ohm will be Vx minus Vy divided by 5. So Vx is 8 minus, and this is minus 0.033 divided by 5. We will get this answer as 1.66 ampere, and this is the required answer for this question. I 5 ampere, current flowing through 5 ampere will be 1.66 ampere. This we got with the help of values of Vx and Vy. So, and Vx and Vy will be calculated when we apply the KCL at each node. And this is the procedure, whole procedure for nodal analysis when we have two nodes. Okay, two nodes with one reference node, two nodes. Okay, this is the basic procedure. Let's see one trick, how to write the equations directly. Okay, by seeing the circuit only, we are going to write the equations here. This is the same question we have solved in this lesson only. Okay, and this is one node, we have named it as Vx. This is the reference node. Okay, V reference, so this is 0 volt. And now we want the current flowing through this 20 ampere. So this 20 ampere. So current flowing through 20 ampere will be Vx minus this V reference 0 divided by 20. That means Vx divided by 20. This will be our answer. When we find Vx, we will get this I 20 ohm very easily. So for that we are going to use the nodal analysis, but we are going to write the equations directly. Okay. Here, see here, this is the node at which we are going to apply KCL. Apply KCL at X node. Okay. So, see what are the branches connecting this node Vx. This is 20 ohm, 15 ohm and 30 ohm. So, write directly 1 upon 15 plus 1 upon 20 plus 1 upon 30 into Vx. Directly we can write. The resistive branches which are connected to that node, we can write like this. 1 upon 15 plus 1 upon 20 plus 1 upon 30 Vx. Okay. Now, equal to, what are the voltage sources connected to this node? Through this 15 ohm, this 50 volt is connected. So, and this is positive here. So, this will be the positive also. 50 divided by 50 plus also this is positive. So, 100 divided by and connected through 30 ohms. So, divided by 30. Okay. When we calculate this, we will get 34.5 Vx equals to 200 divided by 30. That means Vx is equal to this 200 divided by 4.5 is nothing but 44.44 volt, and this is 44.44 volt divided by 4.5 will be 2.22 ampere, and this is the required current. So, by applying this trick, we can write the equations directly. No need to identify all the currents in each branch, then write that equation for each branch and then again solve. So with practice you can able to write this equation. So practice more. Okay. Now this is the next question where this 20 ohm are connected in this manner, and this 100 volt 200 volt sources are connected. This is same as we have discussed earlier. So try this and let me know the answer in the comment section below. Okay. In the next session we will discuss Kirchoff's voltage law and how to apply that KVL to solve a given circuit. Okay, so till then, stay tuned and keep learning. Thank you.